We are wrapping up this chapter with a brief discussion of differential equations. Now, differential equations themselves are an entire course at this university, but we do like to give a preview of what exactly they are in Calc 2. So the idea is that a differential equation is just defining some unknown function implicitly in terms of its derivative. So just like in algebra, we can find some unknown quantity x because we know that x squared minus 1 equals 0. In calculus, we can find an unknown function y because we know that y prime equals 2 times y. Now, again, you can go very many places with this idea. It is particularly useful for modeling real-world actions where we can't directly find an equation for a function, but we can find a relation that tells us how to find its derivative. Now let's start off with the idea of a separable equation. So a separable equation is a very special kind of differential equation and one of the easiest to solve in my mind. The idea is that we are able to write the derivative dy on dx in terms of the product of two different functions. One of them, a function entirely of the variable x that we will call g of x, and the other of them a function entirely of the variable y, which we will call f of y. So x is going to be our dependent variable and y is going to, x is going to be our independent variable and y is going to be our dependent variable. On a different day, we could have picked different letter names, but since we're looking for the derivative of y with respect to x, ultimately the answer to this question should be y equals a function of x. We call this separable because we're able to factor out the influence of all the x's separately from the influence of all the y's in the equation, right? So here is an example. If we were to say that f of y is never equal to 0, we would be allowed to write our derivative as g of x divided by some function, maybe h of y. And in that situation, well, I've got dy on dx equals this other fraction, so I can cancel out those denominators and I get h of y dy equals g of x dx. So there are my differentials. And I got this same rule just from manipulating the differential equation that I started out with. Because I was able to get those x's and y's separate from each other, now all of the x's are on the right side of the equation, all of the y's are on the left side of the equation, and how do I get rid of those differentials? Why, I integrate. Very simple. So when we're working on separable equations, we'll want to rewrite this into a form where we can take the integral of both sides of the equation. Now, on the one hand, we'll be integrating in the variable y. On the other hand, we'll be integrating in the variable x. So we need to make sure that all of the y's are on one side and all the x's are on the other. And once we do that, we'll get some function of y equals some function of x. Let's actually do one to see what I'm talking about.